Hi everybody, welcome back. We're now into the second module of sound properties. And to just simply review, on the first module when we were talking about what is sound, we're looking at air, of course, and where sound basically goes, and essentially the elasticity and the compression aspect of what sound can do. Of course, and most importantly, understanding that when we create those compression waves, that's our control over what we're going to be recording, what we're going to be hearing, what our fans are going to be buying from us hopefully in the future, right? So the idea is that when we are creating sound, we definitely want to look further into the sound properties. And so with that, we understand how sound is created. We understand some of the really beautiful parts about resonance and some of the I think wonderful aspects of being able to get high-end instruments. You could see that you could spend millions of dollars on certain instruments just to get certain timbre, right? But what if we're mixing? What if we're recording one of those instruments? And what if we wanted to, let's say, attenuate further? Or maybe potentially, what if we're working with certain instruments and we wanted to change the pitch? What if we had those instruments? If we look further, we're going to be able to see that everything that we work with in sound has a physical property and a perceptual property. So in this case then, what we're starting on in our second module is sound properties. And the first one we want to look at is physical properties, the measurable properties of sound. And so, for example, frequency is a physical property and is measured in hertz. So like what we were talking in the case of EQ, for example, and I'm just opening Logic here. And if I was to open an EQ module, in this case, and we're going to be doing this, if you've got Logic or if you've got GarageBand, if you've got Ableton Live, if you've got Pro Tools, every DAW has access to EQ or equalization. And what that's going to do is it's going to allow you to be able to boost or cut any of these frequency ranges that we're working in. So in this case, as you can see, on the lower end of the spectrum, we're in the lows, we're in the mids, and we're in the highs. Now, what does that mean? Well, if we're listening to something, for example, if I was just to call up a sound, and I've just got this, very simple sound here, but let's just drag and drop something just for fun. And I'm just going to call up this little simple guitar part here. Now imagine, with this EQ then, this is the timbre and the resonance that's happening in real time with that guitar. So let's measure that then. As you can see here, most of the frequency is happening within 200 to about 4K, right? Now that is very important to note because we're talking about the physical property. That's the measured aspect within hertz. And so in this case, as we look at that measured property, another thing that we could look at on the flip side is the perceptual property created by the brain in response to the physical property of sound. So for example, pitch is the perceptual property associated with frequency. Now, as I was calling up that guitar part, if I wanted to make that guitar part brighter, I could. In this particular case, that would be the physical property. And of course, we can make it really weird and squawky. We start messing with, some of the mids. We can make it even lower if we wanted to add some warmth, maybe. But as you could hear, hopefully, adding and boosting this EQ or this physical property might not necessarily help. Of course, a little bit goes a long way. Something we want to be very, very careful about. But it's something that I really like, and I hope that you will find it's very, very interesting as well and very, very valuable, that we could actually take these physical properties and we could make something, let's just say and use our own words, maybe brighter. Or we could take this physical property and we could add some low frequency to that guitar. But as we were talking about the perceptual property, another thing that I could do is I could actually change the pitch. And so in this case, and this is just a very simple MIDI track, but remember, if I wanted to, I could play that pitch higher or lower in the keyboard, couldn't I? So just imagine then if I took that and instead of using the MIDI information of what we had, and if I moved it up, now we're changing the perceptual property. We're changing the pitch of that instrument. And of course now, obviously, I've ruined the loop because I took that pitch, I changed it. Now it's essentially not the same anymore, or not even close to the same anymore, of course, right? I essentially just moved it up, 1 octave. But what I find very fascinating is that I can change that pitch. And when I change that pitch and we analyze that pitch, you're going to see the differences in frequencies here. Watch. So you can see when we go up the octave, you can see we're at about, 3K to about 8K or so. Now, as we're mixing and as we're working, I find that this understanding is not only easy, I find it very, very powerful. As we start going through and we start looking at these ways that we can attenuate sound, physical properties will allow us to be able to, let's just say, add brightness, add highs, or maybe potentially lows. The perceptual properties, when we start talking about maybe changing the pitch, we can change the note. We can make it, in this particular case, we could change it the way that we're playing it by our keyboard. That's going to change the frequency as well. They're essentially associated hand in hand, aren't they? But one of the things we want to look at is exactly what frequency is. Frequency being the physical property, frequency is the rate at which sound moves through a full cycle. So in this particular case, a full cycle is going to be where we create our circle, or 360 degrees. So one cycle of a waveform essentially is just where we finish our circle, essentially, right? So one of the aspects that I like to point out in this case is that if we are higher in pitch, of course, we are going to have a higher rate. So in that sense, if we're, really high pitched tone in this particular case, we're going to get all the way up here, right? 20K or so. And as you can see here, lower tones are going to be lower in the case of how we're going to be measuring them. So really, really easy in that sense. But another aspect that I really, really like to utilize when it comes down to frequency is that when we look at our waveform view, this also tells us how loud something is. And this is very, very valuable for us. And so obviously when we're working with EQ, of course, we're going to be using our ears. It's very, very difficult, back in the day in order for us to be able to analyze a certain vocal or something like that. But now we can actually call up, a piece of gear like our EQ, and we can actually analyze that frequency as well as we can analyze the waveform. So the waveform view in this case is a graph of the change in air pressure at a particular location and time. It shows the compression and rarefaction. Remember, compression is the top side and rarefaction is the bottom side. And so just for a simple review then, let's just call up a very, very simple waveform. And so I'm just going to do the same thing where I'll just drag and drop, In this case, you see these little blue areas. This is just a waveform, so I'm going to drag that in. And I'll go over this here shortly too. Some of you may be working in Logic in the future and some of you not. But in this case, these are just examples. So just in this case, you could see I've got my acoustic strum. And as I zoom in on that strum, you'll be able to see I've got basically a pretty good road to go, don't I? So the way I see it, we've got a threshold. You see all of this information, this blue up on the outside, and then our waveform in the middle. The way I see that, obviously we would be able to probably utilize this. Now, if I was to take that region, and if I was to turn that region all the way up, wouldn't that scare you? That's going to be very, very loud. I'm afraid to hit spacebar as of right now, of course, because we're going to have problems, and we're definitely going to have, pops and clicks. That's going to be a terrible way to mix. We've got nowhere to go with this particular signal. So, for example, if I'm working with a client, and if my client gives me something that looks like this, I'm going to call them back, and I'm going to tell them that I need your file to be somewhere in the middle of the threshold. And that's what we're talking about here in this particular case of amplitude. And that waveform view really, really helps us. And so in this case, like we were saying, in the last class, amplitude is just a fancy word for volume. And so in this particular case, this is way too loud, right? Too much amplitude. And vice versa, this we would probably need to tell our client we need it to get a little bit louder than that as well, right? So one of the things that I like to point out early on, of course, is that we have to make sure that our waveforms are somewhere in the middle. And I think that that's a really good professional practice to get going here, just to get started. But the best thing, of course, in this particular case is just the fact that we have this waveform view. In the 60s, 70s, and 80s, you could not see the waveform. You'd be looking at the light, like I was telling you in the last lecture. And so as we're looking at our meters, we've got these little lights that are bouncing around, and we'd see certain things go into the red. But in this particular case, to be able to see the waveform view, how nice is it that instead of even launching the session or being able to listen to it, we could actually see that there's going to be a problem. So again, the waveform view is a graph of the change in air pressure at a particular location in time, and it shows the compression and rarefaction. And as you can see here, just like in these examples, it's hand in hand. When it comes down to it, of course, we're looking at amplitude here and being able to turn things up or turn things down. We can actually see that graph now within any DAW or digital audio workstation. It's world class, and it's a wonderful time to be working in audio, right? Another thing that I was just pointing out to you is hertz, and that's the unit used to measure frequency. And so when I call up the EQ, like I was just telling you, this is the channel EQ that we have in Logic. And you'll have an EQ that will be built in GarageBand. You'll have an EQ that's built in Ableton Live, Pro Tools. But in this case, it's really simple. When I call up EQ, think of equalization. Equalization associated with frequency attenuation. So if I want to be able to change my frequency, I'm looking for EQ here in my insert point. And so, and again, I'll go through this right from the beginning, but right now we're just kind of talking about exactly what this is all about. In the terms of EQ, as you can see here, we're starting at 20 and we're going all the way to 20K or 20,000. And as you guys know, that's our human hearing. So if we are able to attenuate from our human hearing, and let's say a client says to us, we want to be able to brighten up a particular sound, we could take this EQ, and if we wanted to brighten up a sound, we could just brighten it up by way of frequency, couldn't we? Or if one of our clients said that they wanted more bass, couldn't we just go down here and add more bass? When I simplify it this way, of course, obviously it's somewhat of an oversimplification, but realistically, that's what I do on a daily basis. I really mean it. It is that easy. I usually kind of just treat it as human hearing. If I feel like something is too bassy, maybe potentially I could just do the opposite and cut the lows out, right? A lot of different ways to look at it, but as the class goes on, I'll just keep firing some of these ideas at you little by little, over and over. You guys are going to be monstrous, right? So again, looking at the unit to measure frequency in this case, and we've got our EQ here, our lows, and as you go back to the diagram here, about 20 to say about 200 or so, right? Low mids, about 220 to about 1K, and then high mids, 1K to, somewhere around maybe 7 or 8. And then 7 or 8K all the way to 10K would be your high frequencies. So in that sense, that's where we got to the idea of our human audio range. Our human audio range is really that simple. What do we hear as humans? We all basically hear similar. Right? We hear similar frequencies, we hear similar ranges. It's not necessarily exactly the same. I think children probably hear better than we do, as you've seen it. My kids, definitely get scared when they go to Disneyland and hear, the fireworks. And at the same token, because we've heard these compression waveforms in our lifetime over and over, and we've gone to concerts and things like that, our hearing is a little bit dulled. So one of the things I want to point out, of course, is to be able to, as I was saying in the last lecture, we want to make sure we protect ourselves, but I really like to point out our human audio range is typically from the frequency of 20 to 20,000. And I'll keep pointing that out, of course, because when it comes down to us as engineers and we call up EQ, you're going to see these numbers as almost like the magic trick for us. If I needed to do any type of attenuation in terms of adding more low end, adding more mid-range, adding more highs, it's really as easy as just thinking about how we hear as humans, 20 to 20K. And so in the case of, let's say, for example, if something is really, really muddy, and the case of, let's say, I hear something like this. I probably wouldn't want to add a bunch of low end, right? In order for me to bring out something like that, maybe what I could do is you could see these crests and these peaks. Maybe what I could do is push back at that. And instead of adding, which I'm doing here as I go over the top of the line, I could actually cut back and cut. Check it out. And in this case, I'm just going to add a little bit of brightness. So in that case, just imagine if we've got a bunch of instruments. What I've just done with a very simple click is I've been able to create more room for that instrument because we don't have as much going on in the low frequency range, right? But with that, it's really quite simple to think of the concept because of the idea that, and again, this is not exclusive to this DAW or this program or this platform. This is equalization in general. They all work the same. If you have an EQ, you're going to be able to attenuate low end, low mids, mid highs, and highs. And they essentially all kind of work the same way. As you continue working with me, you're going to find that I have a lot of different pieces of gear that do exactly the same thing in just a very subtly different way. And I feel that that's hopefully how you're going to train your ears in the same way of why you might want certain pieces. But the key is we all hear a very similar set of frequency ranges, 20 to 20K. So because we all hear in a very similar way, I think that there's something to be said for looking at this chart. Human audio ranges vary from person to person, and they decrease over time. So maybe potentially when we see this chart, there are some people that will be able to hear some of the low end or some of the high end much easier than maybe potentially my grandma or grandpa could, right? Looking at this, it's very simple, and I've got this here for you. If I was you, and I would print this out, I would put this on the wall, and I would be able to see exactly what we're dealing with at any moment. Let's say, for example, you're mixing something, and you see that you're mixing in a guitar. In this diagram here, I can see where the guitar is set. And what this is going to allow me to do is it's going to allow me to see the range of each instrument that pretty much exists. Now, what's nice about this is that it gives us that frequency range. And so as you can see up here on the top, our frequency range as humans, 20 to 20K, just like what we saw on our EQ, right? 20 to 20K on the top. And so with that said, when we start looking at these instruments, as you can see here, that red, when we're looking at that red, essentially that's going to be kind of the heart of that instrument here, right? And then when we start rolling up here, you can see in the yellow area, essentially that's going to be the overtones of that instrument. But the main aspect of these instruments here, it's going to spell it out for us. It's nothing that we have to memorize. And I think that you're going to find that that's going to be very powerful because when we start thinking about mixing, we really need to understand what all of these instruments are doing when we start creating what we're creating. Now, what I love about this also is that you can see that it's kind of giving us, some, adjectives, different ways of looking at what some of these lower end frequencies are. And so if you look here from 20 to 20K, the 20 to like 60, for example, here, right? 20 to 60 in our sub bass, you can see that they're going to kind of call that a rumble, a chest thump, like maybe potentially you might hear that as the low end of the air conditioner or something like that, right? That low end or that rumble, that's going to be very important for people that are working in hip hop, people working in EDM. In terms of myself, it's very, very important in film and television as well because it creates an emotion and we're mixing to a subwoofer in that case, right? So remembering that sub bass, chest rumble, AC ground, the bottom in the case of the bass, we're looking at boom, punch, warmth, all of these different adjectives that we could use for the bass frequency. Again, anywhere from 60 to 200. Looking at our mid-range now, essentially, you might hear the words, like a honk or a whack or a kind of tinny. Remember, when I took that mid-range and we were playing that guitar back, if I was to go into those frequency ranges and attenuate them, it does sound kind of tinty. It sounds kind of honky, right? Listen. It's kind of nasally, right? So very, very powerful for me to understand this in that sense of just kind of, putting a different word to exactly what we're looking at here in terms of our frequency range. Now our highs in our high frequencies, looking at our highs, crunch, edge, sibilance, definition, pierce, or even all the way up to the 20K in terms of air. We'll get to that, but that's a very, very important one for me too, especially when it comes to electronic music. But think of our guitar. Maybe the mid-range is a bad way to go, but let's get to those high frequencies. Those high frequencies create presence. Listen here. I'll take it away. We take those high frequencies away and it kind of sounds like it's underwater, doesn't it? Our highs are very important. So what I like to do is just give it a little boost. And of course, we're going to be doing that over and over and over and over. Right now, I'm just kind of showing it to you so you could kind of see it as it's working. But the most important thing for me is that you understand exactly what we're doing when we add that little boost here to that frequency range. Really just simply in terms of the highs. But doesn't it create a nice presence, a nice air, right? This EQ chart, I feel, is priceless. I use it every day of my life if I'm mixing an instrument that I've never used before. Let's say, for example, if I'm looking for the heart and soul of the kick drum, and if I don't have access to analyze it, like in the case of we're analyzing here, I might not be able to have access to this piece of gear. Of course, this is, like our cheat sheet, right? But if I don't, I can always go back to this, and this is going to tell me, for example, my kick drum is going to be in the heart of, let's say, 50, anywhere to about 500 in terms of your mids. You see where this is set to red, right? So hopefully this helps you. And at the same token, most importantly, just noting that the idea that our human audio range from 20 to 20K should hopefully lock you right into this idea that when we call up any type of EQ or any type of equalizer, it doesn't matter. Let's say, for example, some of you may work for live. I've worked in churches, I've worked in bars. If you're in front of a mixer, you're going to see EQ and you're going to have access to exactly the same thing. Now you'll understand what those numbers mean. 20 to 200 is your lows. 200 to 1K are your low mids, 1K on up to about 7 to 8K your high mids, and your highs up to 20K. And hopefully that will lock you into being able to take many gigs. And as I say to all of you, take my gigs. I'm telling you, that's one of my favorite things in the world is when you tell me that these concepts lead you into the next step. That's the point, right? So in terms of EQ and in terms of the EQ chart, just remember it's really quite simple when we are basically talking about these frequencies and utilizing them. And in the future, of course, go back to these charts, because as we start looking at calling up this stuff in the DAW and actually using it, you're going to see that it is very, very easy to, especially if you can analyze it, to get a great mix if we take the heart and soul of these sources, right? One thing I like to also point out, what are ultrasonic frequencies? Ultrasonic frequencies are above the human range, so we can perceive above 20K. Now, I didn't necessarily know that, or, with that, I wasn't necessarily sure if I would be able to perceive that until I bought a piece of gear. And I think many of you note that, I'd been working with Mr. Gordy, Barry Gordy, for many, many years. And one of the things that I'd learned from him was, I'm learning this from LMFAO as they were working, and going through certain tracks. And I'm really trying to figure out exactly what they're doing to process their material. And they were working with a lot of different producers. And one of the producers was will.i.am. And one of the main pieces of gear that I saw that he was using is the Moog EQ. Now, unfortunately, I was never able to really watch them work, but I do know the gear that they have. And so I was able to, because of knowing that they were using it, I was able to buy this through a couple of my friends. And I realized that, man, this thing really is a magic trick. And it's wonderful because, as you can see here, this piece of gear, it's set to ultrasonic frequencies. As you can see, it goes to 40K. So let's just talk about what and how this is going to work. It's fascinating, right? This is above our audio range. And so if we know we listen from 20 to 20K, then this module is going to attenuate frequencies at 40K, 40,000. So this is going to be 20,000 hertz above your human hearing. And so it's been used by several different people, like I was saying. But most importantly, think of it how you could, bring out the presence of certain vocals. Now imagine certain vocals in today's world, and you wonder how certain vocals sound so present and so in your face. And oftentimes they may be processed through this particular piece of gear. So something I'd like to hip you to is that, maybe potentially for some of you, this could be a really wonderful way for you to really bring things out or to really push the bar in terms of your productions, is to copy and to understand what certain producers are doing through equipment boards. And so oftentimes I might just go and Google a certain person or something like that. So through those equipment boards, I'm able to really learn a lot of different information. So again, with our ultrasonic frequencies, understanding that we can definitely perceive some of these frequencies, maybe we can link into some pieces of gear that will allow us to be able to attenuate some of these frequencies. So in this case, maybe this could be a fast pass on how you could attenuate, let's say, bringing out the presence of a vocal, or maybe bringing out some of our synths, or bringing out a really nice guitar line. This would be a wonderful way to go. Let's try to review exactly the numbers that we're looking at. If I'm looking at here my low-mid frequencies, as you see, as I start linking into these areas, as you start looking at these numbers, makes a lot of sense, doesn't it? Sub frequency, 57, that's going to be your lows. 88, lows. 220, we're getting to low mids, to the mids, mid highs, and then all the way up basically, continuing on to our high frequencies going to 10, 15K, 20K, 40K. You can see here, if I was to go back to the piece of gear that you had, I think that you have access to attenuate a lot more in this case, right? But most importantly, this is analog. And what that means essentially, of course, is that this is made by a certain, it's made by a certain company, essentially handmade. They link it into a piece of piece of gear that's essentially a power supply. This all essentially is analog, of the best in the world. It'll also allow you to link into your subs, as we were saying. So what's some of this aspect? The infrasonic frequencies are below the audio range. And I think that this is very, very important for us as hip-hop artists, as EDM artists. Many of us definitely love the low end, and it's very, very powerful for us. And so infrasonic frequencies are below the human audio range, of course. And many of us know elephants can communicate below 20 hertz, right? So I always think of the importance of 808s. When we talk about 808 kick drums, think of, any type of hip hop, any type of EDM. When we hear that kick happening in that ultra low bass, right? That's a sub frequency. And so we definitely will perceive and feel that sub frequency. So the sub bass of many hip hop and EDM tracks are very important to that genre. And so that's why I love having certain pieces of EQ. And in order for us, let's say if we had a certain hip hop beat that we were playing and we wanted to attenuate more low end, let's just kind of do that. It's really quite simple. I'm just going to call up any drum beat here, of course. And then I'm going to call up an 808 drum beat for those that, if I can find one. There we go. And let's just solo this out. Now, we see our 808 pumping right there, don't we? And as you can see here, I'm pushing that as well. So not only is the 808 hitting, but I'm also pushing it on top of it. We're pushing the frequency up so that we can add more warmth or more low end, right? Some of the reasons why I love this type of gear, because it allows us to be able to get even more into it with that sub. A lot of fun. Of course, you can tell I'm definitely a gearhead, of course, which is why I think many of you guys are taking this class, obviously, right? I think that you're going to find that when it comes down to especially electronic music, hip-hop, being able to attenuate our low end is going to be very, very important. So I don't need to tell you that The sub-audio range, in order to really hear that, you're going to need a subwoofer. So we feel the sub-audio range when the right speaker system is set up for the specific frequency response. It's hitting us into the chest, right? But if we don't have a speaker that's going to do that, we're really not going to feel that. For example, I could put 808s. I could give you the craziest, lowest end 808, from the 80s. It's the best one in the world, essentially. Just the ultimate frequency. And if I was to play that back on my phone, you wouldn't be able to hear it because the speaker on the phone is not attenuated for that frequency response, right? So in order for us to be able to hear this, oftentimes we have to, assume that our clients or our fans actually have a way to hear those sub frequencies. And so that's why certain cars and certain friends and things like that, you'd see that they spend, a lot of money on their car systems and things like that. I sure had friends that way too. But at least in my case, I actually buy a lot of this analog gear for the reason of the fact that I know that many people are going to be listening to this music through their phone. And so I want to try to get as much out of the frequency response as I can out of the quality of the phone, essentially, right? So when, I was kind of doing a seminar and we were kind of laughing about, we were talking about how much money many of us spend to process our material. We spend so much time on processing and mixing and using the right EQ and trying to boost and cut certain frequencies so it's perfect. But we're doing that so that it will play back through a very consumer speaker, through our telephones, for example. It's kind of the name of the game for many of us. And so for me, when I'm mixing something or if I'm hearing something back, not only do I go to my car, not only do I go to my really nice stereo system or my really nice monitoring system at the studio, but I also, maybe potentially most importantly, go to my iPhone to make sure that when it plays back through my built-in iPhone speaker, it actually sounds okay. I think that's really going to help many of you when it comes down to it. And when it comes down to the mixing part of it, or when we're working, frequency is very, very important. We can add too much, we can take too much away. That's going to be a huge aspect of this class as we continue on. So again, we're just kind of talking about it as of right now, but isn't it fascinating to think that you really will have control over everything that you do? It's pretty fun. So what is pitch? Again, to review, pitch is perceived property. It's a measurement of sound made by our brains when we perceive frequency. So pitch is measured in musical note values, right? So for example, the frequency 440 is perceived by our brains as the pitch A, or in this case, let's look at that. What I've done here is I created A in just a very simple MIDI tone. That is just simply the note A. If I was to go down here and let's just say I get this simple keyboard set up, you can see here I'm just simply playing A. Now how do we know that that is A? Well, let's go back to our measurement. A is 440 cycles per second, right? If we look back at our notes. So let's measure that. Let's make sure that that's right. Sure enough, isn't that interesting? What would you expect if I move higher up on the keyboard? And on and on. The higher the pitch, obviously in this particular case, the higher the frequency. Interesting, right? Amplitude, equally as easy, I promise. Amplitude is a physical property, is determined by how much the pressure in a compression wave differs from the normal air pressure. Plucking a string harder increases its amplitude, and amplitude is expressed as the height of the wave in the waveform view. So if something gets louder, we would expect to see that waveform boost, correct? So let's do that. I'm just going to call up our dubstep 808 synth bass in this particular case. Now, remember when we were talking about that waveform and I could see, how does that waveform look to you? Not too bad, right? We've got a middle of the road. We've got some threshold there. As you can see in the stereo field, if we were to cut it right down the middle, we're looking pretty good. How am I looking now? Scary, right? Too loud. Or vice versa. We need to turn that up a bit. So amplitude, I think for many of you, you're going to find that that's also very, very powerful. Amplitude is very, very easy to see because, of course, we have our waveform views. And I think what many of you are going to do, it's a big part of my business, is that I will take these files and I will be able to change amplitude anytime I want to. Even if this file is set, I can change it anytime I want. I could do it through, obviously, the waveform, or I could do it through a volume fader. And we'll talk about that here, but as you continue on, you're going to see that there's several different ways to do exactly the same thing. And that's one of the things I really love about audio is as you continue on, you're going to have several instructors, and we're all doing exactly the same thing, maybe just a little bit differently, but at the same token, we're all doing the same thing. And I think that makes it a really wonderful world. So again, amplitude determined by how much the pressure in a compression wave differs from the normal air pressure. And so amplitude is expressed at the height of the wave in the waveform view, as you could see. So if it was way up in the threshold, obviously you know that's going to be pretty crazy. So what's the unit to measure this? The decibel of sound pressure, or dB/SPL, is the unit used to measure amplitude. And so one of the things we like to point out is when we start right at the start of that graph, we start at 0. That's the threshold of hearing. 0 dB is not when it's off. It's not when it's muted. 0 dB is the quietest sound we could possibly hear. So if you've ever had a hearing test when you were a kid, or maybe recently, right when you start hearing that perceived tone and you're supposed to lift up your finger, that's the threshold of hearing that they're looking for. The quietest sound we can possibly hear. The threshold of pain, on the flip side, is the loudest sound we can bear without extreme pain and physical damage to our hearing. That's approximately about 120 dB SPL. That's like sticking your head in a jet engine. That's like being at a fireworks show and pretty much having the explosion in your ear. So threshold of pain, the loudest sound we can bear without extreme pain, but we still could potentially run into issues, of course, if we're sustaining that sound through a period of time. We could have some issues. Temporary threshold shift is the sensation of having your hearing dulled or muted after exposure to sounds above 90 dB SPL. So we could, potentially run into some serious issues as well, right? So temporary threshold shift usually lasts a matter of hours, but it could become permanent, and that's kind of what I'm pointing out. Threshold of pain, if we're dealing with this physical damage over and over and over and over, you're probably going to have physical damage to your hearing, and we've got to be very, very careful. Even with the idea that we have 90 dB, much less than 120, of course, right? Even with that level, we still could have problems. We could still run into ringing in our ears. For example, I'm sure some of us have gone to concerts, I know I have, and we've listened to music, for probably about an hour and a half, and we go to the bathroom and it's quiet, and finally the reflections are kind of closed in on our ears, and we actually hear ringing in our ears. That's called tinnitus. Tinnitus is the technical name for the ringing in your ears after your hearing has been damaged. So it usually is temporary, or it's usually temporary, but it could become permanent. And so one of the things I point out, of course, is to be very, very careful. When it comes down to you working in a studio environment, many of you are going to be working in private facilities. If you work in a professional studio, what I think you're going to be told is that if your client is telling you to turn up the music too loud, you're going to have to tell them that it is physically damaging your hearing and it's against the law. You're actually not able to turn up above 95 decibel levels, and that is actually against the law because it is too loud. You're actually hurting people. You're hurting it's detrimental to your health, essentially, right? And so what you're essentially protected from through audio unions is that if it gets above 95 decibel levels, you're actually able to tell the client that you have to turn it down, and you're able to do that with what they call a sound pressure level meter. And I'll call up a picture of a sound pressure level meter here when I upload the lecture for tomorrow. And that meter will basically be able to measure exactly the sound pressure level at that time, and you'll be able to tell, if it's too loud or if it's not loud enough, and that's how you would be protected in that case. So I point out the fact that many of you may potentially have private facilities. Maybe you're not going to, have those same protections. Maybe, you might not necessarily measure, the sound pressure level in the same ways. I just say to you, be careful. If your hearing goes, we can't necessarily get it back. And so one of the things I just like to point out, of course, we will all have access to, high-end speakers. We'll have access to, our car stereo systems and things like that. Hopefully now that we've met, we're going to try to protect ourselves from these sound pressure levels a lot better than maybe potentially we had in the past. Be very, very careful. This is our business. It's our profession. And if I hear something too loud and then I go to try to mix something, I'm going to be dulled to those frequencies. Loudness now is the perceived property, the measurement of sound made by our brains when we perceive amplitude. So sounds increased by 10 decibel levels are perceived as twice as loud. And so one of the things I like to point out very quickly then, in any DAW, this is just simply logic. Remember, I can turn something up or turn something down by way of a volume fader. Every DAW is exactly the same way. But one of the things I like to point out in this case is if I have a volume fader, do you notice the numbers? That is set. These numbers are set, hopefully to help you measure exactly how you're bringing your amplitude into your final mix. So as far as your amplitude is set, and we can see all of these numbers here essentially, I point to you, if I go all the way to the bottom, I'm at 60. Now look at this small little movement here, 60 to 50. And let's go back to your notes. Isn't that perceived as twice as loud, that small little movement? Now, let's move that fader up. Notice how that resolution gets a little more finite. 15 to 12, that's 3 dB, and that's about the same distance, isn't it? So what I say to you is then, be very careful as you're working. If our waveforms are too loud, we may take our fader and turn them down. If we do that, we run the risk of getting into this danger zone of resolution. So I just simply say to you, rule of thumb, as I'm mixing, as I'm working, as I'm creating, I want my waveforms to be in the middle of the road, of course. And when I see my waveforms in the middle, they look about like this, of course, right? If they're not, they're going to be crazy, or you're not going to hardly see them. Try to get them somewhere in the middle. It doesn't have to be perfect. We can always fine-tune it later, right, with our volume fader. And hopefully that will help you in terms of your perceived loudness. But remember, to simplify in everything that we've just covered, when we're working, not necessarily even for this class, when we work for anything that we're going to be doing in the future in terms of music, and we start putting sounds together, we're going to be mixing frequencies together, we're going to be mixing pitches together, and we're going to be mixing how loud those frequencies are working together. So just remember, if somebody asks you for more bass, couldn't I use EQ to add more bass? Or couldn't I turn up the bass too? I could do both, couldn't I? That, my friends, is going to make you very, very powerful. So, someone says, I need more bass. You're going to be able to hit them with two different responses and two different aspects of, hopefully, this concept that will help you, push things over the top in the future. Now, most importantly, make sure that you look at this chart. And if I was you, I might maybe print it out. I've got it on my wall all the time, essentially, because it tells me the heart of where these frequencies are set and where, as I'm working with these particular, let's say, kick, timpani, male, female vocals, trumpets, where these frequencies set is if I'm mixing them in a record that I'm using, I'll be able to kind of have the fast pass of where I could, set my EQ, right? I really do hope that helps. most importantly, just remember, if you need anything from me, if you've got any questions, please let me know. Send me an email. I think some of you have, I heard from one, feel free to call if you need anything. But most importantly, just remember that as far as the quizzes are concerned, everything that you see here, it'll be very, very simple. You can use any notes that you've got. Of course, you could go over this and over this as many times as you want to. And most importantly, when it comes down to it, remember that these are concepts, hopefully, to push your projects over the top. All of this is associated with your music, essentially, right? And I hope that this will really, really be very, very simple as far as these concepts. So most importantly, please let me know if you need anything. And when it comes down to it, the next video that I'm going to show you, I'm going to basically just bring you into the studio, and I'm going to show you exactly how we're putting this into practice as far as just some of the heart and soul of some of the ideas of what we've got here. And maybe it'll inspire some of you, to push things over the top in the future as well. I'll be seeing you soon. Thanks again, guys. Hi, everybody. Welcome to the studio. Now, just the concepts of what we're talking about in terms of our EQ. I think one of the main ones that I'd like to point out is that Meg. And there she is right there. And one of the main things about this, of course, is that it allows us to be able to get to 40K. Very, very powerful when it comes to some of our synthesizers. For example, as you guys can see, I've got a bunch of analog synths, attenuating bass, a bunch of really cool string pads, things like that. But what's really nice is to be able to take some of that frequency response that we were just talking about and really trying to bring them out. So for some, they might think, just having the keyboard, is, great in itself. And it is. But to be able to push those sounds further, I think is, just another level. And so it's really quite simple. I'm just going to set this here for you. But like in this module's case, as you see, it's really as easy as lows to low mids to mids to the highs. And it's really, world class essentially. And realistically, as you could see, there's not much to it. It's pretty small. Another one that I like to point out is you could see on your notes, the lecture notes, you could look at deadmau5's equipment board, and you're going to see that he likes to use Neve, and I do too. And Neve has some of the best EQ modules in the world, essentially. And so, as you can see here, this is also Neve. And now, deadmau5 has, 30 channels or so. I've got 2, and that's about all I need, essentially. It's about all I can afford, right? But realistically, we're looking at EQ on that too. So if I was to look at this, as you could see here, I'm not sure if you could see the numbers on that, but you guys are all versed in exactly what that's all about. So as you're looking there, you've got your lows to your mids to your highs, and we can attenuate all the way up. But as you can see there, that Meg goes all the way to 40K. Isn't that cool? Now, one of the things that I've got here too, and one of the big parts of why people come here to work with us, is because I'm a mastering engineer. And essentially, one of the things that I can do is take those frequencies with this guy here. So if you get a chance, check out what the SPL PQ mastering equalizer is. And take those notes that we've just talked about and look at this piece of gear and see exactly what this is doing. It's really not too much to it. There are 2 channels you can see here, and every knob here is basically taking care of some level of frequency response. This will be your low, your mids, and your highs on one channel. Your lows, your mids, and your highs on the second channel. And if you wanted to, you could link them together so that you just do one and then they'll basically be the same if you wanted. But when it comes down to it, high-end EQ is a big part of how I'm able to do what I do as a music producer, as a mixing and mastering engineer. And it's a big part of why people come here is we've got a lot of specific gear that allow us to be able to attenuate frequency in a very, very special way. Now, as far as amplitude and as far as being able to, turn things up in a I think in a very unique way. Back in the day, many people would have a console. But in this particular case, what we've decided to do is instead, we bought a touchscreen console. And so now, whatever I see on the computer screen, I'm able to just basically touch it. I think that's a great way to go because most of us are used to, our phones. Most of us are used to being able to go through and turn things, in this particular case, I've got even my lights hooked up to my phone at this point, right? So we're all used to touch screens. So I feel like, at least for me, I didn't necessarily need a recording console to be able to mess with my volume, but what I definitely wanted to make sure that I had was high-end EQ. So I really hope that spells it out. And again, welcome to the studio, everybody. And again, welcome to the fall 2020 of Cypress as well, guys. But thank you very much. Of course, most importantly, let me know if you need anything. And hopefully the second module will be very, very easy. But most importantly, we're going to get to this and we're going to start talking about what we can do in order to obviously use some of these concepts within our own productions. It'll be really, really easy. We'll talk to you guys soon. Thanks again.